Okay, so with the test tomorrow, we need to review, and I want to start by reminding you that it's not all really difficult problems that take 20 minutes. Sometimes they're nice and easy. So try this one. Let's see how you do. I am putting a 30, 60, 90 right next to a 45, 45, 90, and I'm going to say if this side is the square root of 2, then what are all of the other sides? In case it isn't clear, this one's the 45, 45, 90, and that's the 30, 60, 90. Okay, I'm going to pause for a second, see if you can handle it. So here's a question where we're going to use a 30, 60, 90 triangle to find x, but I suggested to the kids that they write a trig equation. Use sine, cosine, or tangent. And then here's the twist. I wouldn't use a calculator because I'm asking you for an exact value. Because if you use the calculator, you're going to end up with a decimal, which has been rounded and therefore isn't exact. Okay. Pausing for a second. Okay, I was trying to say that, yes, this is a way that works. The 30, 60, 90, 1, 2, square root of 3. And yeah, this way works. X over square root of 3. X is to square root of 3. Like 9 is to 2. Now, that's an okay way to do it. But I had suggested you may want to do this with just using a trig equation, because often on the test we don't use nice 30, 60, 90s. So it would work to say sine, no wait, that wouldn't work for x. I could use cosine of 30 is equal to x over 9. I could have done sine. Who could do it with sine? Yes? So sine of 60 is x over 9. Good. So then you said multiply by 9. I like it. 9 times sine 60, right? Okay. Okay, now, what I was trying to get to here is these answers are exact, but you really can't leave cosine 30 on a test because you know what the cosine of 30 is. You go over here and you say, what's the cosine of 30? Oh, it's the root 3 over 2. Cosine of 30 would be root 3 over 2. So I got to replace that with root 3 over 2. Or sine of 60 happens to also be the same exact thing, root 3 over 2. So final answer would be 9 root 3 over 2. And some of you that are just tied to your calculator so much that you have to type it in the calculator, let me just challenge you with this for a second. You can get sine, cosine, or tangent of 30s, 60s, 45s by just looking at the reference triangle. So let me challenge you with a couple of those. What's the cosine of 45? Should be able to look at a triangle and go, oh yeah, it's root 3 over 2 or whatever it is. Okay, write this one down. So hint, make your little 30, 60, 90 and 45, 45, 90 triangles, your little helper triangles. And what was that first one? My short-term memory's going, I'm old. What did I say again, of 45? I say cosine of 45? Okay, cosine of 45, try that. And figure out tangent of 45. And then how about sine of 30? I don't expect you to memorize all these. I expect you to be able to memorize the classic 30, 60, 90 triangle and then figure it out from that. Okay, 1, 1, root 2. 1, 2, root 3. And dice of destiny, who should I call him? Row 3, second person. Got cosine of 45? Yep. Why is that better than some decimal? That's its exact. Very good. All right. Row 1, person 3.
I got 1.
1. Explain yourself.
So I did the opposite.
Okay. Did you use the top or the bottom one? Because it doesn't matter, but. Okay. And you did what over what?
1 over 1.
Yeah. Very good. All right. And then the last one, row 3, person 3. Yo. Awesome. How many of you have that one memorized by now? It's about the 4th time it's come up. Sine of 30 is a half. It's just one that you should know. It's sort of like saying, what's 1/2? Well, it's 0.5. Have you heard it enough times yet that 1/2 is kind of like, well, get sine of 30 memorized too, because it comes up a lot. I'm not going to tell you to memorize cosine of 45, but I would say memorize sine of 30. And there's a few of them I'm going to teach you later on this huge circle. Anybody know what it's called? Starts with the U. Very close. It's called the unit circle. Yes, the unit circle. And that's going to have some that would be really handy to have memorized. But anyway, one step at a time. Knowing sine 30 is a half is kind of handy. All right. Next, I want to move to, do you remember a problem like this where we had a unknown distance x here? We knew some other things that would help us figure it out. Let's say we have a 45, 45, 90 here. And let's say this side right here is 1. And let's make this a 30. And I hope you get that that gives you a lot of other angles by saying that's 30. All right? You got triangles inside of triangles. Pull them out. Figure out what x must be. Okay. Tell me something you figured out. Raise your hand if you were willing to participate. Yes, in the back. Yep. I agree. That must be a 30, 60, 90, the green one there. Which means that this little angle up there would be how much? I think it's 15? All right. True and good. What else did you figure out? Come on, participate. It goes faster. Yes? You figured out that this was really a 1, 1 square root of 2, didn't you? Okay, awesome. What else did you figure out? Yes? Okay, all right. Tangent of what? Tangent of 15. Now let me make sure I'm figuring out where you're going from. You're going from here. A tangent would be opposite over a, oh, I see what you're doing, but you're not using a right triangle. This triangle that you were trying to use right here, this guy, not a right, and therefore not right. Thank you for trying, though. All right. What else you got? Who thinks they got something? Yes, ma'am. And how did you get this? Since it's a 30, 60, 90, this guy here is a 30, 60, 90. Did you actually draw a little, like, one off to the side like this? I'm just curious. Okay, all right. That's a 1, 2 square root of 3 triangle. And so then you figured out, I'm going to call this h for hypotenuse. And you figured that out to be what? All right. Because this side is 1, then this side would have to be 2. Very good. Because it's the classic dimensions. Okay, so h must be 2. I like it. That isn't what we were trying to figure out, but it gets us closer. Yes, sir. Mr. EL.
Okay. For the we did. Okay, so this is it's a right triangle. So we did.
What's a right triangle? The pink one?
Yeah.
Pink one is a right triangle. Good.
So we did.
Tan of 30
1 over
equals 1 over x plus 1. How many of you approached it that way? I like it. It's a good way. There's more than one way, but that's a good way. Don't be afraid of this just because, you know, like it's got 2 different numbers on it. It's this plus that. That whole side must be x plus 1. Okay? All right. Now, how are you going to get tangent of 30 if the book, or not the book, if the test required exact, where are you going to get tangent of 30 from? Hint right here. Can you do it, Mr. EL? Tangent of 30. I got to replace that now with something.
1 over.
Yeah, from this I can see tangent of 30 would be 1 over root 3, 1 over x plus 1, and then we just have to solve for x. So you could cross multiply. I personally like this way, where you multiply this by x plus 1. And now I've got x plus 1 times 1 over square root of 3 is equal to 1. And then I can multiply both sides by square root of 3. X plus 1 equals square root of 3. And then I'm going to subtract 1. Okay, now that's getting it exact. Would it have been easier if I'd have said decimal? Sure, because you could have just right away swapped out this whole 1 over here, this part here. You could have had 1 over square root of 3. You could have just been a decimal there, and it would have been a lot easier. Yes? I like it. You were looking at the big picture here and saying 1, 2, that's got to be the square root of 3. So x plus 1 has to be the square root of 3. That's a lot faster, isn't it? I like it. There's often more than one way to do these problems, and that's a really good way. But the way that Emil showed you a second ago is the more common way. Why did this one happen to work out so nice? Because I used 1, 2, and square root of 3 for the sides. You know what I'm saying? If this side had been 72.6, it would have never worked out so nice. You know what I mean? Then you'd want to use the way we just did with tangent of 30. All right, that got a little messy, but okay. Now there's a few other kinds. One that I really want to practice with you before I give you this little quiz. Don't get all stressed. It's a quiz you're going to end up taking home as basically a couple practice problems to take home. But this one I want to practice with you before that is the flagpole one. We really haven't had much chance to talk about this very much. So imagine for a moment, please draw this with me. You get a nice blank spot where you got plenty of room. Here's the ground. And have you ever heard of a sundial? If I put the sun up here, do you get a sundial sticks up out of the ground? And then the shadow is cast by the sun on the ground? Okay. Well, I can't remember which way you tilt the stick. I think you tilt the stick towards the sun to do this, but I'm not certain. But it doesn't really matter for the for the situation of our problem. So I'm going to say if we had put the stick in the ground straight up and down, it would be like this. And I even included some went into the ground, right? It wouldn't stand upright unless you stuck it into the ground. Okay. Now let's say you're trying your sundial and it's not working so well, so you tilt it, and you tilt it 10 degrees this way. As in, you grab the bar that's you stuck in the ground, you push it until it's 10 degrees from vertical. After you do that, it casts a 4-foot long shadow and did you get this already drawn in there as a tilted But I'd leave both. I'd leave the straight up and down one and the tilted one in there because you know the angle between those two, right? Okay. And last but not least, I'm going to give you one more piece of information because that alone isn't enough. I tilted it 10 degrees. That's 10 degrees. But also, when I go and look down and I sight for this angle, if I look straight across the top of my pole, that has no angle of elevation or depression, right? All right. What if I say that the angle of depression from the top of the pole to the end of the shadow, if the angle of depression is 20 degrees, then how tall is the pole? I know this involves you having to like figure out what the heck this triangle looks like. I'll give you a minute or two, and if you still don't figure it out, I'll show you. But on the test, you'll have to interpret it. I'm not drawing your triangles for you on the test. I'm going to say it one more time. When you are here looking at from the pole, like right across the top of the pole, the angle of depression was 20 degrees. That is everything that you would need to be able to figure out how tall is the pole. The pole has been tilted, but it's still got a height. Like, it's got a length. The length, I shouldn't say how tall. What is the length of the pole? All right, now, sometimes it's good to have, two heads are better than one, right? And in a moment, when you take this little quiz here, it's got two more questions. They're the, take a little longer kind. The kind where you have true bearings and that kind of stuff. And one of them is a wedge kind of problem. Anyway, you'll practice those with somebody. It'll be really handy to have a partner. So let me pair you up. I want to pause the video for a second. I want to pair people up. Okay. If you haven't picked up what I was trying to lay down for you, it was that is your triangle, and that this is the 20-degree angle. That is the angle of depression up here. Okay? Now, if that's the angle of depression up there, isn't it also a 20 down here? Yes, it is. All right, so now I'm going to blow this up. This should be a trick for you, too. If you get looking at something and it's like really hard to see, make the same drawing but bigger. It's a secret weapon that really does help. Are you with me so far? Who has noticed that they could add one more line and make this into a right triangle? Raise your hand if you've done that in your group. Okay, that was smart. Here's where I'm going to put mine. There is more than one place you could do this. I personally am going to draw it there, and it makes a right triangle right there. There's another way to do it. If you did it another way and you want to keep following that, go ahead. Now the key triangle is actually this pink one, but I hope you've figured out by now that usually you can't just deal with the key triangle. You got to start with a different triangle. So the blue triangle is your first one that you can use. But then at the end, you're going to need to use the pink one to finish the deal. All right, I'm going to pause for a second, give you a little bit more time. All right, 12-minute warning. We're going to finish this problem. And I'm going to send you home with two more that you can start together right now in class. And you'll have a partner, so I'd work with them as much as you can on it. But One other note because I know you're not going to listen to me later. Some of you aren't listening to me now. So anyway, this is the folder called Chapter 10 Review. That's the chapter test you're about to take, right? Do you have to do all of these problems? No, but let me tell you, it's rare when I have problems I can even give you. You know what I mean? Normally we don't have much on a review day, other stuff I make up. So this review worksheet and the key for it are optional, but if you want to study, that'd be a great tool. Rare that I have that for you. Plus, this quiz I'm about to hand out, I have the key for that, and I will post it. So you'll have the quiz and you'll have the key. All right? So those are some things you could do to study tonight and test us tomorrow. All right, so let's finish up that question that we were doing right here. First of all, I hope you know that these two would have to add up to 90, and therefore this must be 70. And if that's 70 and that's 10, then that means this one must be 10 also. How many of you were able to figure that out? Awesome. And now I could just use the pink triangle if I had a side of it, but I don't. So I have to find this side right here, which is not the length of the pole. Okay, the length of the pole is this, I'll call it the squiggly side here. But I need that solid black side. How do I get it? I use sine, cosine, or tangent. Save me some time. What did you get for the length of that? 1.37. Everybody seems to agree on that. If that side's 1.37, I'm going to take my own advice and pull this triangle out and say it's a 10, 90, and this must be 80. And then I'm going to label this with 1.37, and I'm going to say x is the side I want. There we go. So hopefully from there, you could have done cosine of 10 would be 1.37 over x, or you could have done sine of 80 is 1.37 over x, because cosine of 10 and sine of 80 are equal. All right, anyway, then final answer is 1.37 divided by cosine of 10. 1.37 divided by cosine 10. And I got 1.39. Raise your hand if you had that. Awesome. Okay. 1.39, and if this was in feet, you know, that's a weird number, but you took a stick and shoved it in the ground. You can't expect it to come out to a nice number. All right. So, your homework now, and what you work on for the rest of the hour. What I was actually intending was this would be a quiz, but I realized there was no way, because of math day, timing too short, you could finish this thing in class. So just do as much as you can. Take it home. I will post the key. All right? All right. So all I got for the video for today. In case you're wondering what these questions are generally about, I am going to be posting the key for it so you can see them if you're at home. All right. That's all I got for you for the video.